Ooh. Let me start here. um, absolute value graphing. This is chapter 4, lesson 7. In the book, it gets kind of complicated and it gets very vague. So we're going to do it this way to just simplify things a little bit easier of what you need to know. So here's slide number 1. Let me kind of get rid of this. Absolute value. This is your absolute value sign. It's like 2 bars. I'm just going to call them brackets. 2 brackets here, and there's our variable here inside. So our absolute value of x is what we're looking for. Absolute value of x equals x. Absolute value of 0 equals 0. And absolute value of negative x equals positive x. So absolute value of 8 is 8. Like if we have an equation or something inside, 2 minus 2 gives us 0. 0. And absolute value of negative 8 equals 8. The question is, why? If you remember from your vocab, absolute value is the number's distance from 0 when on a number line. So I have 4 and negative 4 here. 4 is 1, 2, 3, 4 units away. So the absolute value of 4 is 4. Negative 4 is 1, 2, 3, 4 units away. So the absolute value of negative 4 is 4. Just because they're going in opposite direction doesn't change that the distance here is 4 units and the distance here is 4 units. Long story short, anytime you're going to have a negative inside absolute value, it will be positive, and positive stays positive. But this is the explanation as to why, because just they're going different directions doesn't mean you have a negative distance. So that's positive 4 and that's positive 4 still. Here's how you graph it. This is the absolute value parent graph right here in red. Our vertex here, where it stops going down, starts going up, is a very important point. And right now, on the parent graph, it's 0, 0. Parent graph meaning we didn't make any changes to it, which we will momentarily. You could see it in function notation, f of x equals x, and then you'll get like, what happens if f is 4, f isn't, or to graph it, you might see y equals x, or absolute value of x. A couple things you need to notice. There are no negative y values in our parent graph, so everything down here is empty, and our slope is mirrored across the y-axis. So when I go up the y-axis, which is the line where our vertex is, if I want to go here, 1, 2, 3, 4, 5, 6 that way, is also 1, 2, 3, 4, 5, 6 that way. It's a mirrored graph right there. Remember, absolute value basically takes every negative and turns it positive. So if I had 2, if x is 2, my absolute value of x is going to be 2. Absolute value of negative 2 is going to be positive 2. Look over here on the graph. If I go over to 2, I got to go up to positive 2 to meet the graph. And if x is negative 2, it's still positive 2 to meet the graph. And it's the same thing with 4, which we saw on the number line. So like I said, this vertex is very important because here on the next few slides, they're going to move the vertex around. This slide talks about them shifting it left and right. And I used h as a variable here because you'll see that again used in this kind of context. So f of x equals absolute value of x minus h. It means we're going to shift h units to the right. So minus h is right. X plus h is shift to the left that number of units. So let me scroll down just a little bit. In red, x minus 3 means we go to the right 3, and x plus 5 means we go to the left 5. Everything stays the same, up 1 over 1 on the slope, all that jazz. It's tough to explain why these are backwards than what you normally think, because you think plus is to the right and minus is to the left. Well, inside these absolute value, to find our point, to find our starting point, our vertex, we have to set it equal to 0. Because we need to be right there where y is 0. So when it's x minus 3, we move to the right 3 because positive 3 minus 3 will give us 0 for y. Likewise over here, negative 5 plus 5 will give us 0 for y in our starting point. Because like if this was 2, we go over to 2 and up 1, 2 minus 3 gives us negative 1, and the absolute value is 1. So it's tough to wrap your mind around these being backwards, but we'll get you a little cheat sheet here in a second, so you don't have to necessarily remember completely. So let me go back. Sorry. Inside these brackets, we're moving left and right. Negative is right, positive is left. So inside the brackets, we're moving left and right. Outside the brackets, we're moving up and down. Inside's left and right, outside's up and down. Absolute value of x plus k. These are like normal, shift up, shift down with positive and negative. Because whatever this ends up being, let's say this was negative 2. The absolute value of negative 2 becomes positive 2. 2 plus 4 is 6. If we go negative 2, we have to go up to 6 to get our graph. Here on this one, we shift the vertex down 2. And in red, obviously, we shift it up 4. And this is still the same V formation that we got here. Nothing is too complicated about this one. You just got to remember, inside the brackets is left and right, outside is up and down. This is the last thing you're going to see. They're going to put negative in front of your brackets. All that means is take the V that's going up and flip it upside down. So this is what it would look like. I took the graph that was just like this, and I just flipped it. Okay, because whatever our absolute value here is, we're making it negative at the end. So if this was 2, absolute value of 2 is 2, so it becomes negative 2. So over 2, down 2. If this was negative 2, absolute value of negative 2, still positive 2, making it a negative, negative, which is why we're flipped. So inside the brackets, left and right. Outside the brackets, up and down. If it's negative in front, then it's flipped. If you see the negative on the inside, then it just depends on the number. But generally, it's still going to be, it's going to end up being a positive number anyway. So here is your little cheat sheet that you need. Write down this equation here. F of x equals, inside the brackets, x minus h, outside plus k. If you have minus h, you're going right, plus h going left. Plus k up, minus k down. Think of this as like a D-pad on like an Xbox controller, PlayStation controller, or something like that. Left, right, up, down. So minus h, plus k, minus k. H is on the inside, k is on the outside. Make sure you write this down so you remember these are on the inside, these are on the outside. Some quick examples. So if I have f of x, absolute value of x plus 1. Plus 1 on the inside means I go to the left. Put one little tick mark, put your vertex, and show me which direction it's going. In my class, that's all I'm really concerned about. Your graphs don't have to be too pretty. This one says we're going down 2. Go down 2, put your dot. There you go. Be careful of the negatives out in front. This one says go up 3, put your dot, and that negative out in front just flips the graph like that. So negative 4 means we're going to the right 4 here, and this is an upside down graph. Now, what if we move up and down and left and right? What's going to happen is, instead of like these up here where we are on an axis, we are going to be kind of out in space. So it doesn't matter if you go left or right, then up or down, or if you go up or down, then left or right. You're going to end up in the same spot. So this one means go to the right 3, and outside it says plus 2. Put your dot, make your V. If you want to go up 2 and then to the right 3, you end up on the same spot. So it doesn't matter which one you do first. Here, we're going to go to the left 1, and then up 5, put your dot, and the negative on the outside tells me it's down. Just be careful. Inside, left and right. Outside, up or down. Negative in front flips your V. It's not going to get too much more complicated than this, and that's pretty much all we have for you.